Hello everyone. I'm actually Li from Hangzhou Qilian Technology. I gave the talk about our HackTrip platform on the demo day, and this platform will be open sourced later this year. I hope you would like it. So today, this is the last panel of the summit. I'm honored to be the moderator. First, let me welcome our four panelists. Stephen, Ken, and Jed, and Paul. You are all famous experts of the blockchain community. I believe you have a lot of fans here, but please first introduce yourself and the recent progress of your project to our audience. So please start, Stephen.
Ni hao. Thanks for having me here. I'm Stefan George. I'm the CTO of Gnosis. Gnosis is a prediction market platform based on Ethereum. Prediction markets allow you to trade information about future events, and if you are excited or want to know what prediction markets are and how they work, I want to invite you to try our beta that will be released very soon. So we'll do a test run of our framework on Kovan. You can sign up and get some play money tokens, and then those who win most play money tokens will be rewarded. If you want to know more information, go to gnosis.pm, and yeah, we will give you and guide you how to participate. Thanks.
Thank you. Ken?
Hello everyone, my name is Huang Lianjing, or in English people call me Ken Wang. Previously coming from CGI, it's a global corporation in the IT outsourcing and system integration. I joined Huawei about 2 years ago, end of 2015. My most focus is really on the blockchain underlying technology, and as some of you may already know, Superchain Qilian from Mr. Li Qilei's company is currently in our public blockchain, and we announced it in our Huawei Connect. So congratulations, by the way.
Thank you.
So the reason why I'm here is, of course, is talking about what we see from enterprise perspective or enterprise application development and architecture perspective, how blockchain, the next generation of blockchain, will go in terms of security, privacy, scalability. So those kind of things, I think we will have a very nice discussion between Paul and Jade and Stefan, right? And Qilei.
Okay, thank you. Thank you, Ken. Jed?
Yeah. Hi, everybody. I'm Jed, founder of Stellar.org. And Stellar's internet-level protocol for payments. It connects banks and mobile money, any kind of payment operator to other ones. So it doesn't matter what kind of currency you're holding, you can easily send it anywhere in the world, because payments today is pretty broken and it doesn't work like the internet. And so Stellar's an attempt to bring it into that world.
I'm Paul Snow. See the previous presentation.
Thank you, Paul. We have several topics to discuss. So the first topic is about the security of the blockchain. Stephen, I know your project is Gnosis, right? As I know, it is built upon the Israel. Last year, the DAO project failed and caused very serious consequences. How do you make sure your project is safe enough?
Yeah, good question. So, Gnosis project has been part of the Consensus company for a long time, and we did many audits during the time we were there, not only for Gnosis but also for other projects. And by doing so, we tried to formalize the process a little bit as much as possible, and created also kind of a checklist or a document. It's called Smart Contracts Best Practices. If you search on it on Baidu, you will find it. It's on GitHub. And this is kind of a checklist already that everyone can apply, just to verify that all the known issues that there are with contract development, that you don't run into those. And of course, whenever there's a security vulnerability discovered, like the AO attack, then this is added to this document, and at least we know that everyone who is applying all those steps to their smart contracts, they are aware that those mistakes are not done again. Of course, that's not enough. It's just like the first step. In the end, I think if you want to do proper audits, you need to think out of the box, because many mistakes, they are not obvious. So based on our experience, it's good to do several audits. So different people have to check the code. They should probably be not working on the smart contract that they audit. There should be someone else. They should try to really understand what the programmer wanted to do. And yeah, we did this for Gnosis now. So we did several audits, making sure that it should be safe. Of course, that's also not a guarantee, so we'll start a bug bounty program as part of every framework that you release, or every smart contract that you release that should hold a lot of money. You should create a bug bounty, because in the end, that's the reason why we need all this. In order to execute smart contracts and to benefit from a blockchain, your smart contracts have to be verifiable. So the source code is open source, everyone knows it. So basically every smart contract deployed on the Ethereum blockchain that holds a lot of money has already a bug bounty, because anyone can try to hack it and steal the money. That's why you should try to basically do such programs before you actually put significant amounts of money in such contracts. And that's what we do also at Gnosis.
Thank you. Ken, could you please share with us some idea to how to deal with the security issue and the solution?
Yes, so like I said before, from my background is more from enterprise application development and architecture perspective, mostly on the security. When we look at the smart contract, it really gives a lot of promise, of course. That's why from Bitcoin to Ethereum, it's a big jump because of the smart contract. But the reality is the smart contract, not many people can program it. And even less people can do it securely. There's four main things we need to consider from enterprise perspective. It's maybe not accepted by mainstream yet, but just from our enterprise perspective, one is we do need a security design pattern when we writing the smart contract. Things like some people already in the network is already said, like you cannot call the external function, like in Solidity, right? If you call it, you need to make sure that you can take back the control, because otherwise you call it, the control is back, and maybe it will cause some recurrency issues. That happens with the DAO attack, as Professor Yang has said. So this is one design pattern. Like if you have to do it, you have to maybe reset, set the balance to 0 before you do a recursive call. Instead of in the DAO, the split DAO program, it has the recursive program. At the end, it sets the balance. So of course, it goes through lots of audit. As I aware, it has some security audit already done, but just from pure perspective, when you read the code, it's maybe not enough. So you have to instill some of a process called the DevSec operation, right? DevOps. Everyone knows DevOps, right? So, but you have to have the security within it. Like Netflix or AWS, they have the DevSecOps. That means the whole process. I will not explore this too further because time limiting, but the second thing is really we need to consider the smart contract. It has life cycle. Not every contract always put there running continuously like agent. When you design your application, you need to think when the contract should end its life. That's very important. Not many people think about that, right? And also when it should stop. Maybe sometimes it should stop if there's an emergency situation, like parity, right? Professor Yang has mentioned the parity. If you have this particular problem with init wallet function, if I have as a writer or also of this smart contract, I can invoke a call, say stop, right? I can call, and if other hacker want to withdraw the funds, it should check this modifier stopping emergency modifier, because in Solidity you can using modifier. Currently there's no, like, we will talk about identity access management, but currently there's no identity access management in the public chain, although it's in the consortium chain it has. So that's the second one. I will try to speed up, right? Don't want to take so much time. The third one is really, Professor Yang also said the formal verification. It's very important, but not sufficient. Reason being, its intention of the programming can be proved by your formal verification. But the intention of what you actually want to do is very hard. So you really need the secure dev, like DevOps, and you have to instill some security into the process. Lastly, it's the Oracle. Everyone maybe know, majority of people hopefully, I think if you come to this conference, you know the Oracle. It's not the database Oracle. It's the connection between the smart contract and the actual world, the data. So this smart contract, the smart Oracle itself has to provide the accurate data for the smart contract to be to do its work. And in the consortium chain, it's easy, like the BCOS. I think yesterday we published the BCOS with Zhu Zhengyuan, right? So they have the idea like how to do it, because you have to have a certificate or have to sign it, and you have to provide the data. You have also economically incentivized to provide the good data. So, in public chain, I think this may be in the next iteration of Metropolis, I don't know, maybe in Serenity. It will have this kind of, what is called the Oracle, which has a consensus. Or somehow, but when you think about how, because the smart contract alone, it cannot do the much work. It has to get the data from the external world, right? So the Oracle has to do this kind of work. Sorry.
Thank you. Jed, please share some information with us.
Sure, yeah. So, I mean, obviously, you know, you have to do a lot of what Ken and Stefan were talking about. You know, the fact that these things are open source helps a lot because there's more eyes on it. You have to have a bug bounty program, things like this. But I think you have to recognize that software always has bugs. Essentially, code is the enemy, and you kind of have to prepare for those eventualities when something does go wrong, and make sure that the recovery from problems is as unpainful as possible, and just do a lot of things to prevent you know, total catastrophe, where it's just stuff that maybe you can roll back from, or maybe it only hurts a small subset of users, things like that, because things are ultimately going to go wrong. There's bugs in all software, so just be aware of that. So.
Thank you. Paul?
Well, I'm going to answer this from a factum approach. You don't do anything. Don't do anything. Just the point is that your contract's data, your data's data, you make sure you can create identities inside of Factum. You can code your contract in whatever language you want and read the data and execute your contract. And then you can record the results. When you find a bug, you can update the chain that's tracking your contract and say, put in your mitigation right there in your chain, and everyone that's running your contract realizes suddenly, oh, they don't have the latest contract, and therefore they have to update, and when they run that contract against that data, they get the updated data and they move right along. There's also the question of, well, you don't want to allow people to arbitrarily update contracts, right? So your contract can actually specify who has to sign an update should an update occur. And if you need a mediator for that, once in a billion time that might, blow up a whole bunch of value because of a bug in a contract. That's never happened, but pretend it did. Then you can have a mediator that signs that this is the updated contract and recover and move forward without messing with the underlying blockchain, at least with Factum, because we weren't ever involved in the first place. All we did was record the data in an immutable ledger and allowed your code to interpret it.
Maybe to add one more thing to this discussion. So it's not only about writing smart contracts, but I think security is also a lot about simplicity. So not only on smart contract level, but also on the compiler level. To give an example, our friends at Augur, they did recently a security audit, not only of their smart contracts, but also of the certain compiler. And they found out that there were several security issues with the compiler, and essentially it was possible to block the entire token transfers of wrap tokens because of a bug that allowed to overwrite some data in the smart contract. And as a reaction to that, Serpent was deprecated. And I think now Vitalik also briefly touched on that. He is developing a new programming language called Viper. And the goal of this language is just simplicity. Not only the language is very simple, but also the compiler should be as simple as possible, so many other people can actually verify it. Because in the end, if you're using compiler, the compiler has a bug, then it doesn't matter what kind of code you write, there might be always a security vulnerability. And yeah, in terms of simplicity in language design, recently Christoph Jens, the creator of the DAO, he posted a question on Twitter, and he just pasted a very short piece of code, and he asked basically everyone on Twitter, would this transaction fail? Would this code, when it's executed, would the transaction fail or not? And surprisingly, the answer in this poll was split. 50% said it was throwing, and the other 50% was saying, oh no, it would not throw. So obviously, this part of code was ambiguous to everyone. And yeah, that just showed that this kind of syntactic sugar that Unity had was not easy or not intuitive for everyone to understand how it actually functioned. And I think as a reaction to that, also Viper doesn't support this kind of syntactic sugar, because in the end it's really about also, even if you know and even if you are writing a lot of code, sometimes your assumptions might be wrong. That's why it's just really important that also the contract language is intuitive and most bugs are not done in the first place.
Yes, thank you. So let's move on to the second topic about the identity management and the key management. Because I think it's much difficult to map people to their identity on the blockchain. But nowadays we have a new technology like face recognition, thanks to the deep learning technology, and we can also use some new kind of smart hardware to preserve the secret key. But people say that code is law, but key is key. If you lose your key, you lose your money. Do you have some good idea to make the key management better and the identity management better? So let's start with Ken. Okay.
Sure. So, yeah. Actually, before I came to this conference, I was in Beijing attending the ISC. It's the conference on cybersecurity. I actually specifically talk about the security and the key management issue as well. I met one very interesting person from a company. He basically manages the key using a composite key. One private key, part of a private key is you holding it. It's, another one is when you use it and the application has to hold it, and the third key has to be a escrow agent. So you have to essentially has like 2 or 3 keys to make the transaction or to do the kind of processing. And if you're losing the key, then escrow key or other key can try to recover or replace your key. From the traditional key management perspective, of course, you have the key rotation. Like you cannot always Like in enterprise, it's very concerned about your key may be lost and you even don't know, right? And it's used in encryption and someone can see your message you even don't know. So it has the idea of key rotation. So every once in a while, you have to rotate this key and you have re-encrypt all the message. So, and also the key escrow, you have to have the agent to escrow your things, your key, and you have the hardware security module to protect your key. So it's traditional from PKI or key management perspective. That can be very well leveraged by blockchain world, right? So just from this key management perspective, but blockchain will kind of speed up this kind of process, the key management. On the other area, we see, what do we see? Actually, I think most people already know, is the identity, self-solving identity, right? Currently, the identity, your information is fragmented. It's in everywhere, in Facebook, in Google, right? You have no control. They can use your data to cash it, right? To make profit out of it. You don't have control. And as a hacker, from the hacker's perspective, the data is centralized. They can just attack. Just to give you an example, Equifax. Recently, 120 million people get hacked. Maybe all you know, right? So it's a centralized database, so people just get hacked. That means where you work, how much house you hold, what's your credit score, all those is a very private information. It's stolen. So that's the problem of current identity. That's a serious problem. And there's no best way to solve it. But the blockchain, I think, provide a potential promise to solve this problem. So it's to have a decentralized self-solving identity. There's many companies. I counted at least 22 companies in US alone doing this kind of self-solving identity, including Consensus, Uport, right, Evernym, there's a lot, Civic, lots of, I don't want to name them all, but they all trying to do it. I think it's a good thing to do it, right? This is one thing. Another thing is really currently the problem with the identity is the access control is really hard. People trying to model it using group-based access control, role-based access control. Recently was attribute-based access control. There's a language called access control markup language, XACML, X-A-C-A-M-L. But there's some products to support that, but not many products. Even Huawei, we try to use it, it's really hard to use. The reason why is the attribute. Once it's installed, it's kind of static. The current identity is using a static attribute. It has to be installed in Active Directory, in schema. It's very hard to extend your schema. You have to talk with your system admin, hey, when you extend the schema, it's really hard. You can try, it's really hard. And even they agree to extend the schema, you have to recompile all your program, restart your things, your application server, right? So it's not easy. So it's currently identity is static. But smart contract with, if we do it well, it promises a new dynamic attribute-based access control. I think that is, like this 22 company, they are not thinking about that yet, but there's maybe other company. If you listen well, maybe you will do something about it, okay?
Thank you. And Jed?
Yeah, so I think the problem of key management is still super hard, and I actually haven't seen a good solution to it yet. You know, there's this trade-off between wanting to keep your stuff secure, but then there's on the downside is if it's too secure, then you lose access to it. I mean, there's many stories I've heard from early Bitcoin days where very smart people have lost access to their Bitcoin wallets because they over-secured it and they lost access, and so now they're just gone, right? So and there's other things too that you have to consider, like what happens if you forget some secret piece of information or you get hit by a bus or something. You want these things to be recoverable by somebody that's not you. But obviously you don't want it to be easily recoverable by somebody that's not you, so you have to end up doing like weird multi-signature schemes with maybe a group of your friends or something like that. It's just it's a very tough problem, and nobody's like come up with a very good solution yet, I don't think. And this has kind of been a problem since the beginning of public-private key. It's more acute now because we're starting to depend on public keys more and more for our activities, particularly like the blockchain one. So hopefully somebody figures it out, but I don't think there's a good solution yet.
Jed, one more question for you about the scaling issue. I know the Stellar project uses a consensus algorithm, pretty much like the Byzantine agreement, right?
It's basically kind of a novel consensus algorithm that's not proof of work or proof of stake. It's sort of, you can kind of think of it as a descendant of Raft or Paxos, but it works in a federated setting. So any server can come and go. You don't have to know all the servers in the network, and it can still reach agreement. So.
How do you deal with the scaling problem? Does the Stellar consensus algorithm scale up to thousands of nodes or in the future?
Yeah, it should. I mean, basically the thing is, you don't have to know all the nodes in the network, so you just have to know like a certain subset of the nodes.
Do you have any plan to sharding or multi-chain architecture?
Yeah, I think right now, currently technically we're working on Lightning networks, so that's a way of getting much increased scalability. I think our platform gets maybe around 500 transactions a second, so we don't really need to think about sharding quite yet. But it's definitely, we spend some cycles thinking about it, and at some point we'll have to. So.
Thank you. The fourth topic is about the privacy issue. Just now, Paul introduced your Vectron, the technology of storing data. But my question is, how do you preserve the privacy of the user who puts the entity on your Vectron platform?
That's a good question. In reality, in our system, the keys inside of Factom aren't really any different than the keys in Bitcoin or any other chain. We have some ideas about using identities to sign transactions instead of addresses. In Factom, you can have an address, you can have an identity, and you can have a hierarchy of keys that secure your identity, which means a higher priority key in your list can update keys of that level and lower. And so you can keep your higher order priority keys in a very secure spot that you don't touch much, and have a key that you're swapping out on occasion to actually sign transactions. And that means that if I lost that key, I actually have a key I can go back to and get it back. And that's actually pretty good, because tearing up and ripping up and throwing away keys is actually a really good way to keep your stuff secure, because I don't know if you've noticed, but the last time I actually flushed my private key down the toilet, I couldn't get it back. It just was gone. And so if you have a key and you have a particular action that you want to take, you put that transaction in and then you just throw it away. It is a reasonably secure way to do a rare transaction, and there's other things. But the point is, if you have a data stream to act as an authority, whether I use a hierarchy of keys or whether at the top level I actually indicate another identity of an organization I trust to be a backup for my security of my coins, then I have at least the opportunity to kind of go back to the banking world if you're comfortable that way, so that if you can't find your password or whatever, there's somebody you can call that will fix you. Some of us are very not comfortable with that, but others of us, like my mom, she absolutely cannot be trusted with a password. She has a little black book just filled with passwords. It's crazy. So yeah, you want to try to build all the options into the solution, because none of those options are going to solve the problem for everyone.
Yeah, regarding to password, I think I will add one point. With blockchain, I think it's really an opportunity for us to get rid of password. Actually, no one likes password, right? In Obama administration, before Trump, they have an initiative of get rid of password, and there's some kind of international standards called FIDO, Fast Identity Online. So if your website, you support FIDO, and then you don't need a password. So basically using biometrics to unlock your iPhone or unlock some of the device or your laptop also has the fingerprinting device, and it will send you a code, you just push your code. So eventually you don't need to remember anything to push you something, a code, a one-time passcode, and you get authenticated. So that's the future. And blockchain, why is blockchain will provide this kind of opportunity? Is of course, blockchain alone is hard. It has to be integrated with biometrics like fingerprinting or iris scan, or the other stuff, right? It's like what you are or who you are. With what you know is password. We don't know about what you know. Right? We just forget it. so difficult to remember. So and blockchain is basically if you have your identity with hash, of course, it has to be kind of privacy preserving way of publish your identity online, and then it can push you through that. Like maybe only 1 minute. Let me speed up, right? So if you go visit one website or you have a mobile application, you want to sign in. And basically using FID or what we said, basically you have a fingerprinting. It's nothing on the server side, it's on your device side, right? So hacker cannot hack you. There's nowhere to hack, only hack your device. It's too expensive. So you basically unlock it using iris scan or fingerprinting, and then it will send you a code because you have maybe your device phone number. So then you unlock, you get the access. That's the future. I think our next generation, they don't know what's password, right? But it will come.
I know there's only 1 minute left. So security and usability, there's mostly a trade-off. And if we see what is being used for banking, for example, or for most services like Google, Facebook, whatever, if you want to make it secure, they ask you to have two-factor authentication, right? And now with any blockchain that supports smart contracts, you can actually implement two-factor authentication using multi-signatures. So we at Gnosis, we are building a two-factor authentication option for you, and you can use it for free, and soon you can try it out.
Can I throw one thing in? Okay. And that is, we did get a contract with the Bill and Melinda Gates Foundation to track medical records for people in the developing countries, because the treatment in those places is very chaotic, and you use biometrics. You use biometrics to find the chain, and then the chain to find the medical information, the history, no matter how many NGOs or disaster relief organizations or governments have come in and done healthcare. So the blockchain is going to solve this problem. Thank you.
Thank you, Paul. We have much more questions to discuss, but the time is limited. So thank you all. I hope you enjoy our discussion. Thank you.